I'm Anil Kumar sharing with you an application test question on sine law. The question here is, the distance between the centers of the circle A and B is 60 meters. Each circle has a radius of 40 meters. Point C lies on the circle with center B. Angle BAC is 41 degrees. What are the possible lengths of AC to the nearest meter? So let me complete this diagram. We have these two circles with the centers at A and B, right? So this is A for us, center at B, and the point is C on the circle B, right? We are also given that the distance between A and B is 60 meters. So this is 60 meters for us, A to B distance. The angle A is 41 degrees. Let me write 41 degrees here. So that's the angle A here, right? What are the possible lengths of A to C? A to C. This is what we need to find to the nearest meter. Now C is a point on the circle. So from the diagram also you can say C could be at these two positions. Let me just sketch these positions. So let's say C is here. So we can form a big triangle. And if there is a possibility, that could be the second, right? But C could be tangent also, right? So there may or may not be a possibility. So first let's figure out if we have two triangles or one triangle. BC is 40 since the radius is 40 for both the triangles, correct? So what we should do first is see if the perpendicular distance is less than 40 or not, right? So this perpendicular distance will be 60 sine of 41, correct? So let's compare BC. What we know here is that BC is less than AB, right? And it's an acute angle. So we'll compare for B sine theta, which is, let's calculate what is 60 sine of 41 degrees, right? Let's compare 40 with this. So we have 60 sine of 41 degrees. That gives us 39.36. Correct? Now since 39.36, that perpendicular distance is less than 40, right? That gives us ambiguous case, right? Two triangles. Perfect. So we are expecting C dash also. So remember that, right? So we have two triangles. So what are the possible lengths? That there are two possible lengths of AC. One could be written as AC, the other one is as AC dash, right? So I hope this part is very clear. Now let's figure out what is the angle C first. We'll find this angle using the big triangle ABC. So let's analyze the big triangle ABC. Now in this triangle we can apply sine law. We know the ratio of A and A. So to find angle, we say sine of angle C over opposite side is 60 is equal to sine of 41 over 40, correct? So that gives you angle C as equal to sine inverse of 60 over 40 sine of 41 degrees, correct? Let's find this angle. So we have sine inverse. Let's put one more bracket. We'll do 60 divided by 40, right? And then we'll multiply this by sine of 41, bracket close, equals to 79.76. So that's the angle, 79.76, right? You could round to 80 degrees. So let's keep 2 points, and then we'll go further. Now if this is the angle here, so that angle is also for this side. So both are, this is also 79.76. So this angle here, the smaller one will be what? The smaller one will be 79, because this is an exterior angle, 79.76, take away 41 degrees, right? So that is going to be, let's take away 41, is going to be 38.76. Okay. So we just worked that out also. Anyway, so that's a smaller angle. But first let's find the bigger angle. I mean this angle, which is angle B, right? Now, so angle B is equal to, so when I say angle B, we are still working triangle ABC. That should be 180 degrees minus 41 minus 79.76. So it is 180 minus 41 minus 79.76. So in decimals, 59.24 degrees, correct? Now, once you know this angle, you can find AC. We need to find the length AC, right? So we can again apply sine law. So we say AC over sine of this angle, which is 59.24, should be equal to 40 over sine of 41, and that gives you AC as equal to 40 times sine of 59.24 over sine of 41 degrees, correct? These are all in degrees. So let's calculate this. So we have 40 times sine of 59.24, and we'll divide this answer by sine of 41. And that gives me 52.39. So we have to round it to nearest meter, so I could round this to 52 meters, correct? So AC, one possible position is 52 meters. Now we'll look into the smaller triangle, which is kind of like this. Correct? Let me write. So here this angle is 41 degrees, and this small angle, which we just worked out, is 38.76. The sides given to us are 60, and this is the radius of the circle from B to C dash, that is the point A, 40, correct? So this is 40 for us. So in this triangle, since this small angle now is 38.76, same formula, so we say AC dash over sine of 38.76 equals to 40 over sine of 41 degrees. So we can say AC dash is equal to 40 times sine of 38.76 over sine of 41 degrees, correct? So let's calculate this. It is 40 times sine of 38.76 divided by sine of 41, which is equals to 38.17, or approximately 38, right? The units are in meters. So we get our answer that these dimensions could be 52 meters or 38 meters, correct? So that is how we could actually solve this question. I hope you highly appreciate what we have done here. So we have used the best methods to solve Feel free to write your comments and share your views. If you like and subscribe my videos, that'll be good. Thank you and all the best.